Now, solution. D part, so we have our Z to be what? Minus what? 3i, right? So which is the same thing as 0 minus what? 3i. So this is the Cartesian form. So what is the value of our x? 0. What is our y? Minus 3. Right? Now, first we need to find the modulus of the complex number. So when we do that, we have this, which is equal to this, right? And it's given to be the square root of what? X squared plus what? Y squared, right? Now if you do this, you have R to be equal to the square root of what? 0 squared plus what? Minus what? 3 squared. Minus 3 squared is what? 9. So we have 0 plus what? 9. 0 plus 9 is what? 9. And the square root of 9 is what? 3. So our R is what? 3. Now our theta. Theta is equal to the tan inverse, which is the adjuvant of the complex number, right? Now the tan inverse of y over what? X. Our y is what? Minus 3. So tan inverse of minus 3 divided by what? 0. Now, minus 3 over 0 is undefined, right? So now, you now go back to your Cartesian plane. You see that now? Your x is what? X is what? So this is your 0, right? Where's your y? Minus 3, right? So your theta is this line. This is 0 minus 3. So your angle is here. So starting from the origin, we have what? So what's your theta? So 270. I said 95. So your theta is 270. Take tan of 270. So that is why when tan reaches this place, it's giving a curve. So the sun inverse our theta is 270. And in radian, what do we have? We need to convert this to radian, right? 3 pi. Is that?
3 pi over 2.
3 pi over 2. When you put pi under, then something is wrong. 3 pi over 2. 2 pi over 2. So 270 is the same thing as 3 pi over 2. This is in radian. So therefore, the complex number z is equal to minus 3i is the same thing as our modulus is what? 3. So we have open bracket cos theta, which is 3 pi over 2 divided by 2 plus I sine what? 3 pi over what? 2. So this is your final answer.